1, 2, 3 into the 4. Easy motherfucking E with the chrome to your dome. Cruising in my 6'4" rag top. I got a lot of juice, a lot of fucking block.
So 8.1 is all about integration by parts. So integration by parts. Okay, and the most important formula is the following. So formally, your book writes it as u of x, so u is a function of x, times v prime of x dx equals the following. U of x times v of x minus integral u prime of x v of x dx. Okay, so I know this might look like a lot, and it does, I have to be honest. So a simpler way that I like to write it or think about it is of just saying u of x. Instead of saying of x, we just consider u as a function, right? And then v prime of x dx, this whole thing is kind of like dv, okay? And then, like I said, the u of x is just u, v of x, because it doesn't have the prime or the dx attached, is just going to be normal v. And then over here, it's kind of flipped around. So our v of x here is just our normal v, and then the u prime of x and the d of x combine to form du. Okay, so if that was confusing, here I'll clarify it in a simpler formula. So I like it, I like looking at this formula more. So we have integral u dv equals uv minus v du. See, that looks a lot simpler than all of these parentheses and x's up here. So basically, so this is your really important formula. This is going to be crucial to all of the integration by parts problems that you perform. So, how to choose your u and your dv, because they're going to give you an integral. So let me go on to the next page. They're going to give you some integral, right? So how to choose u and dv. So let's say they give you, well, okay, I'll just give you the little, I guess, rules or suggestions first of all, and then we'll tackle the problem. So choose u, so that your du is simpler. So when you take the first derivative, then it becomes a simpler term. And then you're going to choose your v, on the other hand, or your dv, right? So that you can calculate or evaluate the integral of dv. And this is the same thing as v prime, okay? So that this can be evaluated. Yeah, so with these problems, these types of problems, the integration by parts, a lot of it is just identifying what your u is in the beginning and what your dv is. And then once you have that set up, then you just use the formula and plug in your values. So let's try an example. So first example, we'll do integral of x times secant squared x dx. Okay, so integration by parts comes into play whenever you have two separate functions of x being multiplied with each other. Okay, so we have to have, I like to do like a kind of a chart thing, not really, but so u and dv, we're gonna have to find these out of what we're given. Okay, we're gonna have to dissect this sort of, so we see which one we want to make u and which one we want to be dv. And then the other values that we will have to figure out after that are du and v. And then we plug everything into the formula and get our answer. So u, going back to the rules, they said choose a u that makes du be even simpler. So if we choose, let's say, secant squared x to be our u, then we're going to have to differentiate that, and then there's a whole chain rule, and that'll be messy. So let's pick our x as u instead. So let's say we set x equal to u, and then so the rest, everything else, so the secant squared x dx is our dv. Okay, secant squared x dx. Okay, so you want to make sure that anything that they give you in the original integral, you're categorizing either into the u spot or the dv. So u times dv should take up everything that they give you. Okay, you don't want anything like off on the side, like a 2 or something, you know. Just make sure everything's included in your u and dv. Alright, so now that we identified those, we can calculate du. So the first derivative here would just be 1 dx, or just dx, either way. And our v, so we're going to have to integrate both sides here. So we're going to integrate, and then what we end up with here is a tangent x, right? Because when you derive that, you can always go back and check to see that v and dv are related appropriately. So first derivative of tangent is secant squared x dx. Okay, yeah, so we're good. So now, ignore those integral signs. So our formula says that what we're given, so u dv, right, is equal to u times v minus integral of v du. Okay, so now we just plug in our values. So u is x, so x times v, which is tangent x, minus, and then we have an integral sign. And then we plug in our v, so tangent x, and for the v spot, and du is now 1 dx, right? And then we can, the 1's just there, or you don't even have to write it technically. So this is the same thing as saying x tangent x, that just stays out in front. That's already, that doesn't have to be integrated again, that's just built into the formula. And then this part though, the tangent x, we have to write that in terms of sine and cosine, and then it's easier to see how to integrate. Sine over cosine, and then dx right here, right? Okay, so now in comes a u sub that we have to do. So I'm going to say make u be cosine x, right? So u will be on the bottom. And then when you differentiate this, du equals negative sine x and dx. Okay, so let me go on to a new page.